Hello everyone, I hope you guys are doing extremely well. Today we are going to discuss a very important problem in our binary search tree series. The problem name is lowest common ancestor of a binary search tree. So let us understand the problem description first. So we are given a binary search tree and we want to find the lowest common ancestor, that is LCA, of two given nodes in the binary search tree. Now, what is the lowest common ancestor? I have already explained you what is the lowest common ancestor in my binary tree series. So I will recommend you guys to firstly look at that video and then come on to this video. But let us quickly understand what is the lowest common ancestor. So lowest common ancestor is defined between two nodes P and Q, such that the lowest node in the tree that has both P and Q as the descendants. Okay, descendants means the children. Now there is one more condition, that a node can be a descendant of itself. Now let us take a quick example to understand the problem statement more clearly. Let us say we are given the root node of the binary search tree as node 35. Now the left child of node 35 is node 25 and the right child is node 45. Now the left child of node 25 is node 15 and the right child is node 30. Now for node 15, the left child is null, but the right child is node 20. Okay, now the left child and the right child of node 30 is null. Now the left child of node 45 is null, but the right child is node 55. Now we are given two nodes. Node P given to us is node 30 and node Q given to us is node 15. So what is the lowest common ancestor of node 30 and node 15? So node 30 is here, we have here, and node 15 is here. What is the lowest common ancestor? So the lowest common ancestor of node 15 and node 30 are node 25, because node 25 is the lowest node for which node 15 and node 30 are descendants, that is the children's. So in this case we are going to return our answer as node 25. Let us say if node P given to us is node 55 and node Q given to us is node 45. Now what is the lowest common ancestor for this case? So node 55 is here. This is node 55. Where is node 45? Node 45 is here. So what is the lowest common ancestor for this? The lowest common ancestor for this is nothing but this node 45, because this node 45 is having node 55 as descendant, and a node can be a descendant of itself. A node can be a descendant of itself. So node 45 will be our answer. So from here, the answer is nothing but node 45. I hope the lowest common ancestor problem is clear. So let us understand how we can solve this problem. So I have already explained one solution of this problem in my binary tree series. The time complexity of that solution was big O of n, where n is the number of nodes present in the tree. Now since this is a binary search tree, we can bring down the time complexity of finding the lowest common ancestor from big O of n to big O of log n, where n is the number of nodes present in the binary search tree. So how can we do that? So we are going to understand the second approach, that how can we solve the problem in logarithm time. So let us take an example to understand this. Let us say we are given the root node of the binary search tree as node 35. Okay, now the left child of node 35 is node 25 and the right child of node 35 is node 45. Now for node 25, the left child is node 15 and the right child is node 30. Now for node 15, the left child is null and the right child is also null. For node 30, the left child is node 28 and the right child is node 32. Now for node 45, the left child is null and the right child is node 50. Now two nodes P is given as us as node 30 and Q is given us as node 30, let's say 32. Okay, we want to find the lowest common ancestor for node 30 and node 32. So how can we solve this problem? So first of all, we are going to start from the root node. So we are going to start from the root node and we are going to compare that whether this root node value is smaller than both the two values or not. So if P and Q both are smaller, that means the lowest common ancestor is gonna occurring in the left subtree of this node, right? Because in the left subtree all values will be smaller, and in the right subtree all values will be greater, because it is a binary search tree. So first of all, so as we can clearly see, this node 30 and node 32 both are smaller, so we are gonna go to the left subtree of node 35. So from here, that is from node 35, we will reach to node 25. Okay, now on node 25, now for node 25 we are again going to compare. So node 30 and node 32 both are greater than node 25. What does it indicate? It indicates that both of these nodes, that means P and Q, will lie in the right subtree of node 25, which means that the lowest common ancestor of these two nodes will also lie in the right subtree. So now we are gonna move to the right. So from node 25 we will reach at node 30. Okay, now we are at node 30. So for node 30, let us check. So node 30, as we can clearly see, Q is greater than node 30 and P is equal to node 30. So what can we deduct from this? From this we can say that Q will lie in the right subtree of node 30 and P is the node itself. So what is my lowest common ancestor? The lowest common ancestor is nothing but this node, the node that I am currently on. So my answer is nothing but node 30 here. And as we can clearly see, we have just processed 3 times. Let us take one more example. Let us say we are given the same binary search tree. Node 35 is the root node, 25 is the left child of node 35, and then 45 is the right child of node 35. Now 15 is the left child of node 25 and 30 is the right child. Now the left and the right child of node 15 is null. The left child of node 30 is 28 and the right child is node 32. Now 45, the left child is null and the right child is node 50. Let us say we want to find the lowest common ancestor for node P. Given to us is node 30 and node Q given to us is node 50. So what we are going to do? We are going to start from the root node. So what is our root node? Root node is node 35. Now node 35 is greater than both P and Q. P is having a value 30 and Q is having a value 30. That means both of these nodes are going to lie in the left subtree of node 35. So from node 35 we will move to the left subtree. So we'll reach at node 25. So now we are at node 25. Now for node 25, if we carefully see, we can clearly see that node 30 will lie in the right subtree of node 25 and node 15 will lie in the left subtree of node 25. Why? Because node 15 is smaller than node 25 and node 30 is greater than node 25. So what is the lowest common ancestor? The lowest common ancestor is nothing but this node 25, because there can be no lowest common ancestor which are going to have descendants as node 15 and node 30. Right. So in this case we are simply gonna return node 25. So what we are understanding, we are just saying that if my current node dot value is greater than P dot value and current node dot value is greater than Q dot value, means the current node is having a value greater than both of these two nodes. So in that case we are going to move in the left subtree. So current node will be updated to current node dot left. The second part is if my current node dot value is less than P dot value and my current node dot value is less than Q dot value, that means both the nodes having the value greater than the current node. So in that case we have to move to the right subtree. So our current node will be updated as current node dot right. Now apart from these two cases, the final case will be our lowest common ancestor. So from else part we are just simply going to return LCA. So let us take one more example. Let us say we are given node P as node 15 and node Q as node 32. We want to find the lowest common ancestor for this. So let us start. So firstly we are going to start from the root node, that is node 35. Now for node 35, the value of node P is smaller and the value of node Q is smaller. That means the lowest common ancestor is gonna lie in the left subtree. So from node 35 we will reach at node 25. Right. Now for node 25, node 15 is gonna lie in the left subtree here and node 32 will lie somewhere here. node 30 will lie somewhere in the right subtree, this part, okay, somewhere here. So now what we can say that this node, the current node that I am on, is the lowest common node which are going to have P and Q as the descendant. And as you can clearly see, this node 25 is the only node which is having this node 15 and node 32 as the descendant. This node 30 is not having node 15 as the descendant. This node 28 is not having node 15 as descendant. This node 32 is not having node 15 as descendant. So our final answer is nothing but node 25. And that's it. That's all about that we needed to understand in this problem. This problem can be solved just using the property of binary search tree. So talking about the time complexity of this approach, the time complexity of this approach in average cases will be big O of log n, where n is the number of nodes present in the binary search tree. And talking about the space complexity of this code, the space complexity of this code will be big O of 1 if we are going to use iteration to solve this problem, and if we are going to use recursion, then it will be big O of log n. Okay. Now let us say if we are given a degenerate tree, that means every node is going to have only one children. So let us understand that as well. So let us say we are given the root node of the binary search tree as node 35. Now the left child of node 35 is node 45. The left child of node 35 is null and the right child of node 35 is node 45. Now the left child of node 45 is null and the right child is node 55. Now the left child of node 55 is null and the right child is node 65. Okay, the left child and the right child of node 65 is null. We are given P as node 55 and we are given Q as node 65. We want to find the lowest common ancestor of P and Q. So what we are going to do, we are going to start from the root node, so from node 35. So as we can clearly see, this node P and node Q, that means this node 55 and node 65 is greater than the current node. So we are going to move in the right subtree. So from node 35 we'll move to the right part, so we'll reach at node 45. Now for node 45, we can clearly see that both P and Q, that means this node 55 and node 65 will lie in the right subtree. So we are again going to move to the right part. So we'll reach at node 55 now. Now for node 55, we can say that node Q will be present in the right subtree because it is greater, and node P is equal to, that means this is our nothing but the lowest common ancestor. So we are just simply going to return node 55. But if we carefully observe in this type of trees, we have to iterate all the nodes in case of worst case. So the time complexity in worst case will be big O of n, and that worst case is nothing but if we are having a degenerate tree. And talking about the space complexity will also be big O of n if we are using recursion, and if we are using iteration, then it will be simple big O of 1. Why big O of n? Because our stack can have at most n entries in it. That's why space complexity of the recursive stack is big O of n. Now what is n? N is the number of nodes present in the binary search tree. I hope the solution approach made sense to you guys. Now we are going to understand how we can implement our logic in the form of code. So let's do that as well. So I'm going to use iteration to solve this problem. Now, as you can clearly see, I have already declared a function called find LCA that is taking the root node of the binary search tree, the node P and node Q. Node P and node Q are two nodes for which we want to find the LCA. Now, these three are nothing but the objects of class tree node. The class tree node is having a constructor that is initializing the value of the node. The left and the right child of any node is by default set as null. Now what is the first thing that we need to do? First thing, we are going to use a variable. So let's call it current, and current will be root. Now till the point my current is not null. So while current is not none. Now what is the first thing that we need to check? The first thing that we need to check is if my current dot value, that means the current node that I am on, if my current dot value is greater than P dot value and my current dot value is greater than Q dot value. So in that case we need to move to the left because we have smaller values of P and Q, so we need to move to the left subtree. So current will be updated to current dot left. Fine. Now the second is elif. If my current dot value is less than P dot value and my current dot value is less than Q dot value, so in that case my current is gonna move to current dot right because we are having values greater than our current node. So we are going to move to the right subtree of the current node, and in the else part we are simply going to return our current, that okay, this is my nothing but the lowest common ancestor of the two nodes. And from this while loop we can just simply return whatever the value of the current after this, if we are not getting into this else condition. Now there is this one thing that I want to tell here, that both the nodes P and Q will always be present in our binary search tree. I'm considering this. Okay, so if that is the case, you need to firstly check that whether node P and node Q are not present. Okay, if that is not, if any of them is not present, in that case you can just simply return null, indicating that both any of these nodes are not present. Now let us take an example to run this code. Let us say we are given root node as node 15. Now the left child of node 15 is nothing but, let's say, node 5. The right child of node 15 is nothing but node 25. Now the left child of node 5, that is root.left is nothing but node 2. So I'm gonna take a small example to run my code, and the value of P is nothing but node 2, and the value of Q is nothing but node 5. Now I want to find the lowest common ancestor of these two. So print find LCA, pass the root node, pass the node P, and pass the node Q. We are gonna check the value of the node as our answer. So let's give this program a run and let us check the output of our code. So the output of the code is coming in the form of a tree node object. So we want the value, so we need to do dot value. So dot value. Now let us check the output. So now as we can clearly see, the output of the code is coming out to be 5. So let's verify our output as well, that how is it coming out to be 5. So the example that I have taken is node 15 is the root node. Now the left child of node 15 is node 5. The right child is node 25. Now for node 5, the left child is node 2. I have taken node P as node 2 and node Q as node 5. So as we can clearly see, node 2 is present here, node 5 is present here. So what is the lowest common ancestor? Lowest common ancestor is node 5, which we were getting as the answer. I hope the code made sense to you guys. Regarding this problem, if you have any queries, please drop your concern in the comment section and I will be more than happy to help you there. Regarding the series, I will be uploading more of the questions in the upcoming week. So keep following us. Until then, keep smiling and keep coding. Thank you.